I'm trying to get these calculus things explained so that they're of use. I'm not so much teaching as showing how the programs work. I hope that you have to practice with them. There's no way you can learn just from watching. Here we have the definition of the derivative, and this is the definition of the derivative. It's that it's the limit as h approaches 0 of f of x plus h minus f of x over h. And we want to show the derivative, show the proof, and then we're ready for short answer questions. So let's just look at this. It's been so long ago since I wrote this, and I guess I was trying to help with students with the things that I saw in class. But let's look at the proof for f of x. This is the limit is for f of x, so we take and put x plus h in everywhere there's an x. F of x plus h, see, this is our function, and expand that out, and we find out that the derivative of x squared is 2x. This turns out, as the calculus goes on, you will see that this is the power rule. In if f of x is equal to x squared, you probably had this in your teacher has probably taught you this already. The derivative is 2x. I go through this with my students. If f of x is equal to x cubed, and then the derivative of that is 3x squared. And we proved this, showing, I put the proof right here for the earlier one, and they all are done similarly. F of x is equal to x to the 4th. Newton must have been surprised when he saw this pattern. And it's 4x cubed. Must have made him scared. It would have scared me. So the derivative of f, if f of x is equal to x to the nth, then the derivative of that function is equal to n times x to the n minus 1 power. And this is called the power rule. And you have to have it memorized. There's so much more to come, so don't think that you have all the time in the world to memorize it. Memorize it now if you don't know it already. So let's put this down. Hide the proof for that, and then the derivative for sine of x. And this is why we had to learn those squeeze formulas. You'll see that the sine of h over h comes here. This turns out to be 1, and it turns out, if you follow this, you can read it as your leisure, or it'll be in every calculus book. If the function is sine of x, the derivative of sine is cosine. The derivative of cosine is minus sine. And so we're ready for short answer problems. What will it prove? F of x plus h squared, it's going to give us, is the setup for a derivative of what? What will it prove? Your function is x squared, so it's going to come down. The function, this is f of x plus h minus f of x over h, and the limit, so that we can tell by looking here what the function was. And it was x squared. What would be the derivative of that? Well, it would be 2x. This is a kind of question they can ask you on the AP test, so it's kind of a strange way to put this. If you see this, what would this prove? Cotangent of x plus h minus the cotangent of x. This is the setup to prove the derivative of the cotangent. What is the derivative of the cotangent? The answer to this problem is minus cosecant squared, minus cosecant squared of x. Sorry, check, we win. New problem. The derivative of tangent is secant squared of x. Close parentheses, check, we win. New problem. The derivative of cosecant is minus This is the one that's minus cosecant x, close parentheses, cotangent x, close parentheses, check. We win. We go back. So the short answer questions are the way that these tests will show up on the AP quizzes. And they will see whether you understand the setup for proofs. And I did this program mostly as a response to the confusion that my students had when they saw a question posed to them like this. What is this? They just didn't know how to answer that. And they're really checking to see if you understood the nature of the definition of the derivative and the way the proof is set up. So, take care. Have fun. Get good. Bye.